Hello and welcome to this video. In this video, we will learn about type conversions using from and into, and we will also see TryFrom and TryInto. So as you know, suppose we have an integer is equal to something like 18, and this integer is I8. Then we can say that let y from I32 is equal to x as I32. So this works in Rust where we can convert primitive types using as. However, for complex types, it does not work. For example, suppose there is a number. By number, I mean integer. Okay. And we want to put that integer into a structure which contains a number. Then you simply can't say as. So to do that, we have from converter used from std convert from. If you mouse over this, it has all the description which you can read for yourself. There is quite a bit here. So the signature of impl block is impl from. You give the type into angular brackets I32. We want to convert I32 for this structure, and the function name will be from. It will take an argument of the type specified here, I32, and it will return a self. Self means number type. So here you can assign item to value. You can initialize number from item to value. So this is the from implementation. And with the from implementation, we can convert it like this. We can say let num number is equal to number from 30. Like you have seen something like let s is equal to string from hello. So we have seen something like this. This comes from this kind of implementation where this is ampersand str and this is s is a string, so it comes from there. Once we have this implementation from, we can also invoke into, because from implementation also provides us into. With the into, we can say that int, where int is an I32, int dot into, and it will give us number. Okay, so the function would look something like this. Okay, now you have to be careful here that when you implement from, you should not implement into. We'll look that into that in a bit. So here the number is created from an I32, and here an I32 is converted into number. Both are essentially the same thing, just that the names are different and how they work is different. So from is an impl block for number, while into is an impl block for I32. So here I32 is converted into a number, and here number is created from I32. So from the English difference, there is not much difference. So if you want to run this, you can run this. We can run this. I will print my number is value colon 30 and my number is number value colon 5. Now what we do is we comment this out and we will bring this on. And then although from provides an implementation for into, the reverse is not true. Into does not provide an implementation for from. Now if you see this, it says that in the second paragraph, if you see, it says one should avoid implementing into and implement from instead. Implementing from automatically provides one with an implementation of into thanks to the blanket implementation in the standard library. Refer into over from when specifying traits bound on a generic function to ensure that types can only implement into can be used as well. this trait must not fail. If the conversion can fail, use TryInto. So that is the reason we should not implement into typically, other than in this specific case. Now, if we run this, we get my number is value colon 5. So that is how from and into work. Now, as you read, the implementation must not fail. But what if the implementation can fail? For example, there are cases where you can take an input from keyboard. That input can fail. The user may by mistake enter a string which is not a number. So, or there can be other cases whenever you have external sources of data, if the conversion can fail. So in those cases, we use TryFrom and TryInto. So if you look at TryFrom, so in this case, we have a structure even number or which takes a number I32. So we have a type error which is of unit type. It has nothing. It is basically an empty tuple. It is unit type. It is not even an empty tuple. It is just empty. So these parentheses are called unit type. So TryFrom will take a value, okay, I32, and it will return a result. The result may contain self, that is even number, or it may contain self colon colon error. The error will be created from the empty type. Now what we are doing here is, since this structure's name is even number, you can guess that if value is an even number, that is when divided by 2, remainder is 0. In that case, we return OK, even number, value. We construct an object of even number with that value and wrap that in OK. And the unit type error is wrapped in error. Because if you remember from our discussion, a result type contains either an OK or an error. Now, once we have this, we can say that even number colon colon rise from 8. So 8 is an even number, so we know that it will return okay, even number 8. So we do an equality assertion here, which will succeed. Similarly, for 5, we know that it will be error case. Similarly, when you see TryInto, in that case, we take 8 and we try to convert it into an even number. So in this case, there will be no error, but we will have even number. Okay, so it will be result comma okay even number. The type of result is the type of this error here. So here self is even number and this error is empty type. That is what is specified here. Similarly, if you try to convert 5 to this result, it will contain error. So equality assertion will be succeeding. So if we run this, all assertions will pass and there will be no error. So there is no error. The assertions have passed. Now again note that we only implemented TryFrom. We did not implement TryInto. So this is how we can convert one number type into second number type. So I think this video I will end here. And both the examples have come from the Rust by example. You can go and read there as well, but there is nothing more to it. So in the next video, we will start learning about closures or closure. So closures are very interesting and we'll see how they work. So I hope that you have found this video useful and it helps you understand more about how you can convert one type into another type in Rust. So thanks a lot for watching. Happy programming.